Welcome to part 31 of the Switchwire saga at this point. Um, well, we kind of like continue where we left off last week. So last week we already wanted to install this 48-volt power supply. Didn't quite work out because we had a little bit of like problems with the belts, which I think we actually found like a really nice solution now. I did not do too much between streams. The only thing I did was I fixed the camera mount. Um, Let me just like move all this stuff out of the way for a second. So last stream, we basically had the issue that the camera here was sitting like too low. So basically this new mount is mounted on top. Hi there, Steve. And the old mount was basically mounted here to the back. So basically now the camera is like, I don't know, like 7-8 millimeters higher up. And that basically is what I need to clear the bed. So I think what happened, I see like there's not like quite a like comfortable gap between the camera and the bed. I think what happened is just that the tool head sits a tad lower with the new mount, and that's why the camera was then too low basically. But yeah, you can see like now the nozzle touches now, and there's still like a 3-4 millimeter gap between the camera and the bed. So that's like perfectly fine. That's all I need. The only problem is like if the camera points down, it will touch the bed, but yeah, it worked out so far. It's the same how it was before. But yeah, I want to have the camera quite low so I can see basically below the cartridge, the carriage here. But yeah, like overall, I think it's like really nice setup now here also with the blocks we added. I also did run input shaper. It looks okay. Like it's not tremendously good, but it's not horrible. Hi there, Steve. So let me check. I think I might have deleted that. Let's actually quickly turn it on. Then I can show you the graph. So basically, it turned out to be like an EI input shaper, which is okay. So my understanding was always that you need MZV is like the best. I actually saw like a really interesting interview with, I forgot the name of the guy. He's like the input shaper guy of the Voron Discord. And it was a really interesting interview about input shaping in general, all the things around it. And like I learned in this interview that EI is perfectly acceptable. So EI and MZV are both good enough. And I get EI, so I'm fine. Not gonna chase unicorns, basically. Let me see if this is already online. Yes, it is. And then let me just open that here in Chrome. Here you go. So this is basically input shaper I get, which is okay. So basically, I think this is quite typical, this peak here, the second one. Here, something is not 100% okay. I think without this, we would be an MZV. But yeah, so EI is totally fine. Right now, we have a recommended acceleration of 8,600, which is actually way more than I had before. I'm not quite sure if that's because of the different mount. Before I was like around like 4,000. So not quite sure what happened there. But yeah, let's see what happens with with 48 volts. So yeah, let's do the following. First, let's turn it off. Flip it over. Get the old power supply out. Get the old steppers out before we forget that, because they will be completely fried if we turn it on with 48 volts and old steppers. And then I would just double check all the wiring very quick. Just checking that all the connectors are correctly crimped and everything. Everything is tight when it comes to screw terminals. Just everything like looking good. Just like, yeah, quick sanity check. And then we can just swap in the power supply and the steppers. we need to check the manual, basically, what we need to do with the steppers, because they work differently than the 2209s. So basically, the 2209s go out, and we get TMC 5160. So yeah, let's just turn off. Let's turn it off. Let's give it like another 5 seconds. Okay. Let's just move it already where it will go in a second. And let's flip this bad boy over. Okay. So just like as a first inspection, that's something I did off stream a while ago. I added like this 80mm fan here. So the steppers have direct airflow, basically. There's one fan here blowing air in, and this one also blows air in. So basically everything, I blow air in everywhere. Yeah, and then the app will like escape through all the little openings around the printer. This is the power supply. That's HDR 124 from Meanwell. This one will only power the steppers. So this also at the moment only powers the steppers. And we will replace that with basically the same power supply. So this is really a drop-in replacement. This is HDR 148. So it's the same power supply, double the voltage. Yeah. So let's take it apart. Also we'll make sure to have like a longer arm soon, so we can like zoom out a bit more. Let me get my little screw catch-all. Yeah, and I think like one thing I still didn't do, I still didn't connect this LED strip here. And I'm kind of considering at this point to just like redo that, to be honest. Because I was never 100% happy with it. And that might just be like a project for the future to redo the LED setup a bit. In the meantime, I discovered the COB LED strips, the ones where basically they have like way more LEDs than this. So the light effect looks much better. Yeah, and here I just basically cut like 2 holes in the acrylic glass and printed these fan grills. Okay. Let's see. Let's just get this out first. Let's see. VHP tape. How can we do that without destroying everything? Sometimes think it's clever to have like a pull latch on the VHP that you can kind of like pull out. I do see a bit of VHP sticking out here on top. Oh shit, that's not a VHP tape. That's the there's this little notch here. I started from the top and thought it's VHP tape. It's not. um, okay. Let's just dazzle a bit of alcohol under it and see if that helps a bit. Like VHP tape is amazing until you have to remove it, and if you have to remove the backing tape. These are the two scenarios where VHP tape is horrible. And I think I might have used a bit much here. I think it gets a bit loose. If it would have something to like hook under it, that would be amazing to kind of pull up. Okay, I think we're getting there. It just hurts. Let me see. Do I have any tool I could use? Because I mean, technically, if you remove the pedal, it will be like way easier to like get under it. But ideally, I don't want that. Well, you know what I could do? I can use a bit of cable. Manage to get that under there. I might have a chance of pulling on it. Yeah, okay. I got it. God. What a mess. I think that's a good trick. To just like pull down. Okay. Let's use less VHP tape. I think that's a bit much. But it's like very easy to remove. That's like another thing I really like about it. Like it's very easy to just peel off and it's just gone. There's like no residue, nothing. So that's really nice. Cool. So this one will become an LED power supply. This will make my home pretty. Okay, the new one is exactly the same. It's a bit of a shame. Like I would really like to have like a DIN rail under it. It has a really nice clip. You can just clip it and then like it sits on the DIN rail. I'm pretty sure it's just too tall with the DIN rail. Yeah. I mean, most likely you can bend the acrylic a bit over it. It's just it will. Let's just quickly try that. That works. Okay, let's do it like that. I think I have a half thin rail. So I have 3. I'm pretty sure. That would be really ideal, like if it would be like coupling. Could reuse it, but yeah. Let's use the full length here. And maybe we can put something else on it in the future. Oh, if I add VHB tape under it, will be even a bit higher. Let's see. Let's see. IDT. Yes, it's a very Steve heavy chat. Okay, let me just do one quickly. Let's see if this holds, or not holds, if it's like too tall. Oh, shit. Now also the orientation is different. Ah, no, that will not work. And we have to redo the cabling and everything. No, let's just glue it back. Same as before. That's the bottom. Yeah, exactly. I just flipped it over. Okay. Let's just use less VHB tape. Okay. Okay, then this one is plus. And this one is minus. I just wonder whether I should like mark this one a bit differently because it's like 48 volt and not 24. Just like from color code perspective. I do have a bit of like green heat shrink. Yeah, but it won't fit over. Yeah, it's okay. Let's just give this like a little mark just that we know maybe in the future. Okay, let's also quickly double check that everything here looks fine. How's the progress of your other printer? What did we do last? We did the clicky probe, so it has a clicky probe, and that was the last thing we did, like 3-4 weeks ago. I'm currently a little bit like constrained with time that I have to spend to work on printers things in general. So the other printer is a little bit on hold, most likely for the rest of the year. Next year I will have more time again, and then I'm very happy to continue working on it. But for now, it's a bit on hold. Like the main problem with the other machine that we still had was that the print quality was not good. Like was like very, I'm not even sure how to describe it. Like uneven. I think is a good description for that. Um, uneven. Yeah. So that's something we still need to figure out. I'm not sure what is it caused by or what causes it. Here we go. Let's make a mental note. This is plugged in the center one. Very careful because we also like unscrewed the main board. Hey, there you go. Yeah, that's something I modeled in Fusion and added. So it's just like basically like a custom mount here for this fan. Mounts in the 3 mounting holes of the mainboard. So this bracket basically also holds down the mainboard, and it just gives like air to the stepper drivers specifically. So the stepper drivers have like a constant flow of fresh air. I remember it had weird artifacts in the walls. Yeah, exactly. That's what I mean with the uneven. Like, yeah, it was just like I'm not sure what it is, to be honest. Like, just like I never saw this pattern before. My suspicion is still that it's like caused by the y-axis mount. It could be just the mount of the bearings. Could be something worse. So yeah, let's see about that. But yeah, it's for next year because it's like working on the other machine like costs a lot of time because I have to model and prototype. And these machines are, you know, like easier to work on. That's why, like for the rest of the year, we will work on the switch wire. The LEDs might be something I want to do. And the V0 also needs a bit of like maintenance and stuff like that. Some LEDs are broken, so we might also do that. But yeah, from next week, I'm going to stream for sure. The week after might be not possible. Like I'm currently moving to a new place, and I'm working in a new place to like make it nice with walls and floors and stuff. Most of my tools are already there, so what I have here on table is all the tools I currently have here. um, and then at some point also like some stuff will go there, and yeah, might be very messy. Okay, so these are the new stepper drivers. I don't think they look like tremendously different than I mean, it's the same pinout. So the blue one is the TMC 2209 and the red one is the TMC 5160. It's a bigger heatsink. That's pretty much all I can say. I mean, the stepper driver itself looks much bigger, like the chip here on the bottom. It's quite a bit beefier. Let's quickly check the manual, how we need to configure these jumpers. So, no, it's not mellow. It's God, Menta M4P manual. Let's quickly download that because I really don't like the GitHub inbuilt PDF viewer. Okay, let's quickly check. So for TMC 2208, 29, 2250, 5160. Oh, there's a TMC 5161. I have no clue what TMC 5161 is. SPI mode of TMC drivers, for example, TMC 2130, 5160, 5161. Use 4 jumper caps for each to connect the position of the red box. So basically, we just put jumpers everywhere. If I have jumpers. Where do we have jumpers? Might contain jumpers. Oh, let me quickly grab the box of the mainboard. I'm back in half a second. All four in the same row as the one for the 2209. Yeah, all four, Steve. Yeah, just all the jumpers. Didn't know TMC 5161 existed. Me neither. I have no clue. My curiosity is peaked. What is 5161 versus TMC 5160? H-bridge MOSFET transistor external to the driver chip. Those external MOSFETs have a very large, very low resistance, so low heat. TMC 5161 has the MOSFET integrated. So I guess the 5160 is better because it has the external MOSFET. Oh, sorry. So it's the external versus the internal MOSFET. That seems to be the difference between the two. So nothing too major. Oh, give me 1 second. Something is messed up. Here you go. Okay. Then this box should have all the things we need. Oh yeah, also like we wanted to add canvas to the V0 at some point. That's also still on my to-do list. Lots of goodies. Let's see. So we technically need calculation. We need like nine jumpers. Six. And 9. And then actually let's remove, because we had like one extra stepper, or like the board has 4 slots for steppers. We only use these 3. So let's just remove, oh, I broke it. That's the first. Okay. The corner broke off. Doesn't matter. Okay, let's just punch all of them in. Need just to be a bit careful with the board, because it's not really like properly mounted at the moment. I'm still very happy with this board. Like, it's like really simplifying the entire printer setup. And if this wouldn't be required, if I would have the M5P with the integrated canvas adapter, it would be even better. But unfortunately, the M4P doesn't have the canvas adapter, which I'm still a bit sour about, to be honest. I mean, it's not a huge biggie, because really it's only like this extra tiny board here that kind of like tacked on as a piggyback kind of setup, but still, I like things pure and simple. That's it. All the jumpers are in. Let's just quickly double check that with the manual. So we set now these 4 jumpers on the top position. So the bottom row is free, which is the case. And for this one, we didn't set any, only for the 3 here on this side. Same here. Voron's now running the M8P and CB1 with onboard can. Yeah, I think that's like a supreme setup, to be honest. The CB1 is much better than I expected. Like, I expected it to be kind of like a crapshoot, to be honest, like performance-wise, but like it works really well. Like, there's no extreme loading times or anything. It just works. So the CB1, I'm really happy. And the CB2 is even faster. Like, I just got CB1 as bundle with the board, was super cheap, so I took it. But yeah. Let's just search quickly in the whole document for 5160 to see if we skipped something. No, it's only 2 here. And that's just in the introduction section. So this is it. That means we just then need to configure the steppers in Clipper. before we put in, I mean, technically it doesn't really matter, right? I was thinking like maybe before we put it in, we should double check the connections. Let's just quickly verify that we didn't screw up the two power supplies. We didn't accidentally mix the cables or something. Going to try CB2, so no SD card needed. Yeah, I mean the SD card, if you don't need it, that's also like a benefit. You know, I have a talent in breaking SD cards. So just quickly checking that this one should go here. Yeah, so this is not connected to the 48. This one is the 48. And then just to double check. Yeah, this is 24 and not 48. So this one is all 48 volt connection here. So let's just quickly double check the pinout of the board that this is supposed to be 48 volt. Before we do that, let's quickly do a bit of cleanup here. So this is like another 2209 because the board came with 4. Let's just get the 5160s with the red heatsink all out. Also there, I have 4, I only need 3. Like, they always come in 4 packs. I think it's not the worst idea to just have one spare. You know, if like stuff tends to happen sometimes with my printers. So having some spares is nice. They only have there's the last one. Okay. No, this one. This one's in there. And this is my. I still have to like clean up quite a lot of stuff. I will reorganize everything in my new apartment, I think. So I will have more space for stuff like that. Okay, let's just be careful with these. We can put them in a hot second. So we wanted to check the manual. BLTouch is amazing for their motherboards because they send all the extras. Yeah, like I mean, you just saw the goodie bag with all the connectors and everything there. It's like really nice. Like I'm a huge BLTouch fan. Also like the Mellow board I had now on the other machine, the Micro 4, I think it's called, from Mellow. It's a really nice board, and they also give like a lot of goodies. But the documentation is noticeably worse than the BLTouch documentation. So with BLTouch, like I think like you get like a really good like combination of things. Because like this is really easy and clear here. And it's all in proper English. And with Mellow, like the English documentation was a bit weird, so you always had to go to the Chinese one and translate that. And that one was way better. Speaking of good manual, pinouts here. This is what I wanted. Yeah, now we see here like the one on the outside is a 48 volt. So that is correct. So we have 48 volt on the right one. We didn't screw up so far, which is good. I'm using the BTT Kraken in my DIY tool changer, loving it so far. Yeah, I mean that's a really amazing board. Do I have the right board in mind right now? I think it's the premium one, right? Yeah, exactly. Yeah, I was also like tempted to get this, to be honest, at some point, but it's too big. It's too big for this machine. Like you see, like the M4P, the M4P is such a perfect fit. Like there's really like no space left. You see, I even had to use the 90-degree adapters here to make that fit. And Ethernet is not an option anymore because that's blocked by the 90-degree adapter. But yeah, it's a perfect fit. Okay, let's throw these in. I hope the heat sinks are not too tall for the fan. That would be like a bummer. Just make sure that's all the way in. The fan is as high as it can be, so I'm carefully optimistic. I did I printed out a cable channel the other day. It's wonderful. Thank you. You're welcome. Here it is. I think it's a really cool addition to this machine. Like it's a bit finicky to install, I think, because like you really have to find the nuts under the thing, and there you if you undo it and the nuts move. God, I had like some very terrible very terrible minutes or hours with that. But generally it's a really nice thing. It just allows you to organize all the cables in a very neat way. Moment of truth. Yeah, there's plenty of space, I think. Yeah, plenty of space. I mean, if we have cooling issues, we can even do an upgrade there. Use like 2 millimeter thermal pads to like lift the heatsink bit up. Then we can have like one big heatsink under this fan, technically. It would be like a cool upgrade. I'm not quite sure if the TMC 5160s have like a temperature sensor or something internally that you can query. That would be really handy. I know some of the step stick drivers, they have like little LEDs that show you the temperature. So let me just quickly clean up all the tools. I use double-sided tape. Um, you will see the temp now of the drivers in UI. Oh, amazing. See if that's good to know. So they do have a temperature sensor. Let's see how it looks when we boot it up and configure everything. I just use double-sided tape. What do you use double-sided tape for, Dom? For the heatsinks? I also use double-sided tape for heatsinks on Raspberries. Not gonna lie. Uh, I think that's technically like the hardware change that was needed to be done. So we have a 48-volt power supply. We have new TMC 5160 drivers. That's it. Now the fun part starts. I mean, so far everything goes to plan. Let's see how long that lasts. Do we want to have a magic smoke camera? Let's do a magic smoke camera. So I guess we're ready. 3, 2, 1, fire. Looks good. You have a plan when you stream. You mean like in the next weeks or because Fridays usually. I bet you know that. Um, no magic smoke. I think, yeah, once I had Magic Smoke with the toolhead board on this machine. Um, with the toolhead board, yeah. By the way, shall we quickly verify it's 48 volts, just like for the loads of it? Not that I like accidentally sold us a 24-volt power supply. Your streams never go to plan. Hey, this one so far goes to plan. Oh. Oh, do I put this that you can see what I see? It is 48 volts. So that works. And everything is okay. So we did not plug something in the wrong way. Hi there, Adam. Welcome back. You just joined at the right moment. 48 volts is installed and running. So we'll do a bit of configuration, but I think this should be quite straightforward. I wonder whether we should configure this fan as exhaust. At the moment, like this blows in and this blows in. Maybe it would be good if this one like just pushes air in and this one just pulls air out. If you have like a little circle, like circular ventilation here. I mean, it's also open here on the back. So if this pushes air in, it will just like blow out to the back. But let's see. I mean, now we see temperature, so we can see what the steppers are doing. Nice progress you're making. Almost done, I guess. Well, yeah, I guess. Today the fun is more in the experimentation. I'm a bit afraid, to be honest. Like scared is maybe a better word. Um, because this has so much power. And I need to check what's up there. Well, oh, Clipper didn't boot up, of course, because of the steppers. Yeah, exactly. Stepper X. No Team CU art. That's very sad. Who would have thought that we don't have Team C UART anymore with a different stepper? So let's close this. Let me just close like all the random tabs I have open here. Clipper Team C 5130 config. Let's quickly check the BTT Manta 4P config. Maybe they have a sample configuration for us. Oh yeah, they have 5160 configuration here. So let's just take this over. We just need to like sort the steppers. Oh wait. Steppers. So let's see. So basically we can check the pin this one and the pin that we used on stepper X. And then we can kind of like determine which stepper goes where. pin out. Okay. So these are the, you don't see them, but here's the stepper pins. So we're looking for something with PC9 and PB12, I guess. Or PG6. PC9, PG6. PC9 is this one. PC9, PC5, PB0, PB1. Oh, this one has PC9, PC9. So this is the stepper Z. This one here. So, okay, then we can identify. So this one becomes the stepper X. Let's just comment this section out, and the section that was like commented out before, we can X that. And then we still have the TMC auto tune, which applies all the magic values for us. Then let's take these two, stepper Y. So there's one with PC10. So stepper Y is stepper Y. So that's good. So we can comment out this section, kill that section, comment in this section. And they're also configured with a stealth chop. This one was stealth chop off. But I think the stealth chop's overwritten anyways by the auto tune, so that is not really a big issue. And then we have PB12 and PB12. So this one is also fine. So this becomes stepper Z. So X and Z basically are just swapped. And let's actually just remove the... let's comment out the stealth chop. Because this should be really done by the TMC auto tune section here. Because there you have tuning goal, performance, or silent. So that will take care of all the things. And then here we also turn it off. Run current, that's not a question, right? So run current before was 1 ampere. But basically, because we have 48 volt, the work? Work is doubled because like the voltage is ampere times voltage. So if we keep 1 ampere, but the voltage goes from 24 to 48, we have double the work basically that is performed. So if the run current 0.5, that's equivalent to 1 ampere for 24 volts. And that's like why 48 volts has so much more power, because you double the power basically that is available to the stepper. Let's just start chill. Let's just put to 0.75. Let's keep it a default value. Let's keep it a default value. Check it works, and then we can step by step go up. Okay, let's restart the firmware. TMC 229 stepper X. Oh no, what happened there? Pin chip name. Where did I forget something? You have no sensor set. The sensorless. It's set. It's diag pin here. Here. Yeah. Okay. Gotcha, Steve. This one is the problem. I'm just a bit confused. Like that's exactly what we copied, and it said like in the sample config it said 5160, but here it says 2130. So I'm a bit confused about that. Let's just double check that in the okay, let's see. I just assume that they are the same. Yeah, here, TMC 2130 or TMC 5160. So I assume it's just the same config block. I'm looking at I'm looking for the reference. But this is not what I was looking for. I was looking for like the whole here. Fans, LEDs. Yeah, there's the TMC 5160 section. Yeah, the example config T, it has TMC 5160 and then it has TMC 2130, but I think that's just not correct. Let's just rename that. I think that's just a copy paste from them. It's most likely they actually work the same. PG10 is not a valid pin. I think the sample config here is complete. That. I think this is just nonsense. What is in the sample config here? Scrap whatever I said about big tree tech and good documentation. Okay, let's check the pin out. CS. So let's just quickly check because like what we have as X is not what is there on X. So we identified it with the diag pin. So the PC9 is our X. So the Z here, exactly. So the CS pin is PC9. Check. Then we have diag pin is, let's check what the diag pin is. That's bridged to the Z end stop then. So that's PC2. Yeah, we can actually just copy that over then. PC2. The question is whether we need that pull up there or not. Let's leave it out because it was not in the config. And then SBI1, I think we need to keep. So basically, we just need to copy the diag pin over. So it's PC1, PC1. What Menta board are you using? It's the M4P, the one with the 4 steppers, the smallest one. And then here we have the diag pin for Z is actually not set because we don't use the sensor is homing on Z. So let's just comment it out. Yeah, like if you go back 10 minutes in a stream, I had the printer flipped over and we were working on the board. Let's see if it works now. Okay, and then I was told we now see temperatures. Steve, where would the temperatures be of the stepper drivers? But let's just start with baby steps. Set kinematic position X 100, Y 100, Z 100. So basically this command allows us just to set the position manually. So the printer now thinks it's homed and it's at this position. When they're running, okay. That's now they're running, right? Now the steppers, they're not engaged. Why are they not engaged? Because right now, like it's home, so they should have engaged. Let's see what happens when I move in X. Oh, now they are engaged. Okay, check. Okay. Yeah, so X moves correct in this direction. Z moves up, moves down. I was like, quickly, my plan was to move Y, but I saw Y here and then press this button. Stupid of me. Y positive moves forward, which is correct. Seems to work. Just a random question, but how many people do you roughly think use Octave? How many printers do you think are connected to Octave? I have no clue, to be honest. I see the install numbers in the Play Store. In the App Store, I actually don't even check those numbers that much. I would guess like it's a question: how many do we have it installed and how many use it? I have no clue. I would guess it's like a 6-digit number. Guess low 6-digit. Installed, that is, not use. Let's see. Homing. Technically, we could start trying to home. Because these are like new drivers and everything, let's just set the stall guard as to a very high value and then just gradually walk our way down. So the 255 is the high sensitivity. So let's quickly restart the software and then we can just start X, and most likely we'll just move like that much and stop because it's too sensitive. Let's just home X. Must home X's first. Cool. That's not well. Okay, let's also set like a very high value for Y and then just home the whole shebang. Um, yeah, here we have 75. That would most likely kill the machine. So I just set 200 for both. Let's try it. Okay, so way too sensitive, which is great. So X didn't move at all. Y moved like a tiny bit, but also in the wrong direction. Yeah, Y moves in this direction. I start to believe that Y is incorrect. So first, let's decrease the sensitivity. Let's just do quite a large step to 175. Same for Y, right? And then the direction. So I think we need to invert the direction for whatever reason. Or is there something missing? Because like it moved the correct direction. Let's quickly check again. Okay, so still the same. Let's reduce the sensitivity again. And step by step. I wonder what this error is coming from. I think because we don't home Z, something goes wrong. Because it tries to move most likely after Z isn't homed. I just like to double check. So if we move in Y, so if I increase the Y position, right, the badge should move forward, which it does. So I think this is correct. There might be something off with the homing. But let's just get it to home in any direction first. I'm again like wondering if this one has actually effect, because we had it before that that didn't really have an effect. Yeah, like it doesn't change. Like I basically halved the sensitivity quite a bit now. So if I move, okay, just the homing is broken. I mean, it also now moved again in the wrong direction, but now it was like very very hard. So I think the homing is just broken, which is interesting because it definitely worked before. Let me go again with the strength to 175 at least, because that was like quite rough and very fast. I'm not quite sure why it homed that fast. The homing speed is set to 50. So we do a set kinematic position and then we do homing. Then let's maybe also just quickly check the macro, what's going on there. It does print this, right? Let's quickly look at the logs. What does it say? So if we now home, it says home to do y, x, y, x, and then it has the must home axis first. So it says to do Y, to do X, then it does this, then it does this. And I think then it tries to move to the center, and that doesn't work. So let's move this in the if here. But yeah, I never had issues with this homing macro. It's the same like for a very long time, which is very odd. Like I'm confused that it homes in the opposite direction that I'm expecting, but moves in the right direction. So let's move XY, home XY. Now we have the same again. Like it doesn't print the error, but it's definitely not doing it correct. Ah, this is so weird. See, Steve, now it's going wrong. And if I set it again to 150, oh, I also see the chat window in stream is not correct. See if I can fix that. Yeah, no, it's wrong in a different way. They keep changing this chat box in YouTube. I have like this like couple of CSS snippets to like remove the input and stuff like that, and like it keeps changing. It's horrible. Okay, but this is kind of okay. I was a little bit irritated by the webcam, to be honest here. So let's quickly home again. Yeah, like this doesn't move at all. And then when we had it at 125, I think, is when it just like slammed to the side. I mean, it definitely moves and everything is fine. It's just like the homing does not work at all. I wonder if there's something different between the step drivers when it comes to like the diag pin or something. I mean, we do not have the pull up here. Let's try that, right? Because before we had the pull up and we know that the sample config is pretty crap. So let's see if this maybe makes a difference. It's funny, like this always moves like just like a tiny bit forward. But yeah, no difference there with the pull-up resistor. Let's quickly check the here in the machine we can query the end stops. So X and Y are already triggered. Can show you my config for the MP4, but with the 2240 steppers, MP8. I had a big city tours. I wonder what happens if we just invert the pins. But Steve, yeah, feel free to shoot me your config. I'm not quite sure how similar they will be. So I think it's like exclamation and then the thing. That was Y. Oh yeah, other way around. 50-50 chance. 50-50 chance. Yeah, now all the end stops are open. Let's see what happens if we home X. Ha! And quite smooth. I would, what value do now? 125. Let's try 135 because it's still like had a bit of pressure. And for Y, Y was like requiring a bit more strength before. So let's just see how it goes there. So I think why it moved the opposite way is it wanted to like unload the end stop. That's why it moved forward and like this direction. Okay. I mean, this worked quite okay. This was really hard because it was already on the. It's always like if you home while you're already on the end stop position, it's always a bit hard. Now this is tough. We don't have to like super fully tune it, but I would like rather be now on the lighter side because the steppers will become more powerful if we like start increasing the amperage. So I'd rather have it like a bit soft now. It's still very, very tough. Let's do a bigger jump to like 200 and see what happens. Still quite a hit. Man. Okay, let's just do 230. I'm not sure if this has any effect, to be honest. Because we had it that like before, like I was changing this and like it was no effect whatsoever. Yeah, this has no effect. Let's quickly check the config here. Man, that thing has a lot of options. Is it SGT? I struggled with mine for hours and I had to do a homing macro because I could not get the homing to work without it. I already have the homing macro. I'm SCG, stealth drop, sensor, hold current, run current, interpolate, chain. Okay, but like it's homing, so it's not horrible. I'm just like, if you compare it to the 2209, right? You have this setting here, SGTHRS. And I think that's not the same setting for here, which I guess might be SGT. TMC 5160 clipper sensorless homing. See here? SGT, it's a different setting. So it's SGT's minus 64 is the most sensitive, 63 is the least sensitive. So the scale is completely different. That explains a lot. Okay, let's check our config here. The problem is now we have this auto tune plugin. So let's remove this here, here and just set this one here. Let's just set it to minus, I don't know, 50, which is like relatively sensitive. My homing macro lowers current speed and sensitivity. I think we talked about it before, T, right? Might need to do it too now with the 48-volt system. It's still kind of the same. And it's minus 50, so I don't think it will, it takes this. Let me quickly disable the auto tune and see if that does something. Yeah, like right now, T, I think the problem is just that like it doesn't take the setting at all. Like it's not this sensitivity isn't good, it's just like it doesn't take the setting. That's my interpretation of what I'm seeing. Yeah, see now it took it. Now it stopped immediately. So we need to, most likely this is called different. Because so basically I have the auto-tune plugin that will override all these settings. So if I set it here, it will just be overwritten from the auto-tune plugin. So the TMC auto-tune GitHub. Let's quickly see if we find something about that here. What if you lower the homing speed? Yeah, yeah. It's just the setting is not effective. So it has support for that. See? Reading the docs. So it's just SGT. It's just called SGT. So we're just setting the wrong value here. Let's just keep that there. Minus 50 was way too sensitive, so let's just go with minus 10. Okay, so very sensitive. Let's just set 10. Yeah, it's just trial and error. It's a bit annoying. No, it didn't stop at all. Well, let's try minus 5. Set it 0 or 1. Okay. Let me try minus 5 quickly, Steve, and then we'll go to 0. It's still like way too sensitive. But yeah, maybe like what we can do is like we tune now the values for the 0.65 amps we have at the moment in the config. And then we just modify the homing override to always set that amperage. And then we don't have to worry if we now later change the amperage to redo that. Yeah, it's still too sensitive. How about we do that right away? Let's just set it to 0.4 amps. Just really low, or like 3.5, just really low value. And then let's also set that to 10. So we just tune now the homing first, and then we do the other thing. The other thing, aka everything else. Yeah, see now it doesn't stop again. Let me try 5. I didn't try 1, Steve, yet. One I should also try. Let's try 1. Um, 1. Steve, you were right. 1. So 0 doesn't work and 1 works. This is very. I mean, who am I to judge? If it works, it works. Let's try it with 0.25 amps. Maybe it's like a bit weaker then. Yep, that looks good. That looks fine. And then for Y, it works perfectly. So I'm not quite sure if we should change something there. Let's apply the same run current of like 0.25. And then we set the SGT of 0. I'm pretty sure 0 is just a standard value. So most likely nothing changes really. Maybe we can try 2 for the sensitivity. No, 0 for sensitivity again. Yeah, so this one didn't work now. Why did not work? Let's quickly check if Y moves okay. Yeah, Y doesn't properly move, so we need more power. Most of the info I found for LDO said it will be 0 or 1. So you have like 128 values and it's exactly the middle. Sure. Okay, so this does not work. Let me quickly see if it's the value or the run current. Let's put the run current back to 0.8. I mean, if it's 0.8 and we can home at 0.8, like, it's fine. No, this doesn't work now. So it's definitely the value. Let me remove this. Maybe it's 1. Maybe we need the same one there. Okay, now this worked. So it's definitely a 0 value there. Mm, let's load the run current to 0.4. Try again. That looked good. So let's try SGT1. Oops. I mean, we are almost have it. We almost have it. Maybe. What's happening now? Okay. Yep, that works. So it really needs the SGT1. SGT1 is important. One last attempt. Let's first conf. Try just a run current 0.3. If that works, then we are good, I think. No, it doesn't work. Does not work. Okay, let's stick with 0.45. Here we go. That seems to work. Perfect. Cool. Then let's update our macro with these values. So the steppers now have 0.25 for X, which also like is quite interesting. Like we should have also changed Z, right? Because that runs at 0.8. So it's also like very let's do both at 0.4 and see how that goes. Just an explanation, right? We have A and B motors here. In Clipper, one is X and one is Z. That's why we also need to update Z for the X. Let's try. Yeah, that seems to work. Let's quickly try 0.3. The motors are much smaller on AB, so we can most likely get away with a bit less current. Yeah, now it's also like way less like perfect. Okay, this now works really well. Okay, so now we need to check what T was doing. Clipper. I was surprised how little current I could run on my motors with the 51.6 compared to the 22.9s. Well, do you also use 48 volts or like are you still using 24 with these drivers? Um, so basically we need to do this for each stepper. So in the macros, in the G28, let's first do this, and then we set driver config X 5160 stepper X. Hold current we don't need to touch at all. Then we need driver config Y. So this is X, this is Y, so we just saved it. Then we run this TMC set current. So basically we just change it. So for X, we said 0. Let me quickly check what we now set. Steppers. So 0.3 for X and Z. So it's 0.3, 0.3. And for Z, it's 0.3, 0.3. And then for Y, it's 0.45. So we just save X and Y. And then at the end, of this whole shebang, we set, let's not even touch the hold current. Run cur X. So we just set it back. And we just apply the X for X and Z, so they're always the same. That makes sense. And then here we do Y. So if we save this and then steppers, let's change this back for XY to 0.65 for now. And for Y, it's 0.8. Let's see if that works. 24 volts. My motors don't even get warm, and now I can run speeds faster than my Bamboo X1C. I thought about upgrading to 84 volt, but I don't think it's needed, honestly. Yeah, I fully agree. Like, even with the 2209s and 24 volts, like last stream, we reached like 18K acceleration on this machine. So yeah, it's just for fun. Wait, what was the arrow? Unknown tag run cur X. So what I did was not correct. I thought I know what to do. Without the percent. It's just like this. Yeah, it's really just for the fun. I also, the power supply we just pulled out, I will need it for something else. So I would have needed to buy like another power supply anyways. So it's really just the drivers. And to be honest, having nice drivers is nice. So it was pretty much just like why not? Let's see if we can still nicely home. Looks good. And we see the logs that we say the current is updated. So basically it just sets the run current, the hold current and run current to the same values. Then let's save the hold current as well. Just like if we change in the future in the config, I will forget that we do that, and then bad things happen. Takes like 0.5 seconds to quickly do that. This was just hold current. Let's call this also XZ to just make clear that this is the same for both. And try the whole thing one more time. There's not really like a delay. When you hit the home, it first executes the current commands and takes like a bit of time for some reason. That worked. Then let's do a speed test. So let's just start quickly with low value, just to like make sure everything works. Nothing explodes. I have the emergency stop button. That's very slow. Is it quieter? I think it's quieter. It sounds a lot quieter. Like it's really, it's not loud. Like it's loud, but it's not noisy. Low flying. Done. That was like not a lot. Okay, so it works. Last time with 24 volts, we capped out at 18K, I think. Yeah, so 16 it did, 18 it did not. Let's try. We didn't like up the currents a lot now, so let's just see if we get or let's do 16, what we completed successfully with 24 volts. They're not warm at all. Where's the bottom? Oh, there's nothing. They're barely hand warm. We don't even actively cool the motors yet. I wonder why this is so slow, like this horizontal move. Like I did not remember this being that slow. Yeah, I'm a bit scared, to be honest. Always like before it like starts. Okay, here we have skipping. So the amps need to go up. Let's see. So at the moment we are at 0.65. Let's just set it to 1 amp. I think that's also what we had before. Exactly, we had 1 amp before. I don't see temps at the moment, Steve. Let's quickly check in a second. I don't see any temps. Where should they be if they would show? Okay, so I just have the same amps now as before. TMC 5160 temp clipper. Maybe it's only on the 2240s. Mm, maybe, is there some extra config I need to do? I don't see anything here. Mm, no, I don't see anything regarding temperature. Maybe Steve, can you check if you have like some special config somewhere that enables that? Okay, let's try the exact same as before. I'm really not sure why it always homes like twice before the speed macro. And then does this very slow move. The entire table is shaking. Steppers are not warm. Not at all. So that was 16,000. Let's try the 18,000 that did not work with 24 volts before. Software Mozy Miso pin. Okay, let me check these pins. Because it would be really nice to see the temperature of the steppers. Mozy Miso, yeah. I'll check the documentation in a second. Make sure the table is all the way at the wall. Here we go. That's 18K. I don't think my hotend can print that quick. Okay, before we check out some higher speeds, let's quickly check the Miso Mozy. Um, let me see the 2240 configuration. SCLK. So I think that the SPI pins we can Mosi Miso. Yeah, it's the same for the 5160. Okay, we'll be on the pinout. Yep. Yeah. SCK Miso Mosi. So you think they are they the same for you for all the steppers? Because yeah, it must be right. They're only one block. There is only one block. Let's see. Um, yeah, they are all the same. Okay. Yeah, makes sense. Let me also check the TPFD. Let me just do it for one first. And technically, we can just copy it down. Clipper config. Oh, wait, I'm not where I'm supposed to be. T. Oops, that's not where I'm supposed to be. Here we go. TP. Well, I'm not quite sure. I don't think this has something to do with the temperature. Some register, I guess. Okay, let me quickly copy this down after checking the pins, of course. So the SCLK is PA5, MISO 6, MOSI 7, MISO 6, MOSI 7. Yeah, so it's exactly the same pins. Let me put that here too. And here too. Let's see what it does. SPI bus is not a valid section. Do you have these configured, Steve? SPI bus? The pin corresponding to chip select line, this pin will be set to low at the start of the SPI messages, raised to high after. Not the SPI bus, yeah. So I think these are just like exclusionary of each other. Common SPI settings. Let's just read in the common SPI. Common SPI. SPI bus. If the microcontroller supports multiple SPI buses, then one may specify the microcontroller bus name. Here, the default depends on the type of microcontroller. And then we have the 3 pins we just said. Specify the above parameters to use the software-based SPI. This mode does not require microcontroller hardware support. Generally, any general purpose pins can be used. The default is not to use software SPI. Let's see. So it's basically they exclude each other. No, I still don't have the temperatures. The first driver to integrate the real temperature sensor with TMC 2240. So I guess 5160 just doesn't have it. Which is a shame. Yeah, I guess then let me quickly undo the change we then did. I think that the stepper driver just doesn't have it, which is a shame. I would love to see that. Oh. Hmm. Temperature sensors. The driver integrates a 4-level temperature sensor, 120 C pre-warning and selectable 136, 143, 152 emotion. Okay, so it's not a real temperature sensor, but it will shut itself off when it's too hot. Ah, that's a bummer. Okay, let's see. Where did we left off? So we did 18,000. Let's just try 25. See what happens. I have the emergency stop button handy. We should do like a speed benchy. Not today because I have the wrong nozzle, but I mean there's a variable high flow on this machine, so it can push a bit. But I think for a speed benchy we need a 0.4 millimeter nozzle. I have 0.6 at the moment. Yeah, I was skipping. I'll be back later. Need to eat. Enjoy your food to receive. Okay, so this did not work yet. I mean, it did skip. I'm a bit surprised because we now like increased the amperage quite a bit. We increased it quite a bit. Didn't pay attention. I think it skipped in XY. We do have enough heat headroom for the stepper, so let's just increase the run current a tiny bit there. Maybe let's try. If we now try something else, like we will not know if that helped. Let's just try 25 again. Here we go. No, it still skips. It still skips. Let's see. I don't think like it's a current issue per se because we like throw 1.2 amps at it. I wonder what happens if we just disable the auto-tune. What does that do? We then do need to set this SGT manually, because otherwise we have a problem for the sensor zooming. We check the CNC 5160 section. Which one was it again? It was the driver underscore SGT. So let's just set it here to 1. For that, we keep the auto tune on. Oh, wait. That was Y. Let's still set it there. And then let's also set it here to 1. And let's stick with 25K for now, just to see if we have an improvement. No, it's still loose steps there. I'm pretty sure it must be some setting, because technically you should be able to do it. Let's try let's try let's quickly try 22. Just see what happens. Yeah, T, like I can push it to 1.5A, but I would have expected it to perform better. So I'm not quite sure. Like, I mean, the motors are cool. That's not a problem. Stepper drivers, I don't know. We don't have temperatures for those. Let's see if it does 22, and then I think we can push it to 1.5 should be fine. Let's quickly check the specs of the drivers before we do that. Yeah, it does it again. I'm just trying to see if it like loses in Y or in X. Let's set to 1.5. Before we run it, we quickly check the specs. So it's a TMC 5160 Pro BTT. So that's the stepper driver we have. So we have this Pro section here, so we are perfectly fine in the voltage range. Maximum current is 3A. And that's because of the pins. What I'm wondering is, does the stepper actually get 48 volts? Because there's the jumper. Did we set the jumper correctly? No, let's try 1.5 ampere. But then let's also quickly check if we configured it correctly. Now it passes, so I guess more amp, more better. The motors are still, how to describe that? Um, they are, I really wonder why it always hits like here in the corner so hard. It's really weird. I think the travel distance is a bit too large, maybe the config. But yeah, motors are barely warm. Barely warm. Let's quickly check that the motors get 48 volts. How can we do that? We can flip it over and quickly check the pins. Maybe we can do like a visual inspection without taking it apart. That would be really cool. Yeah, I think we can look through the fan. Okay, there's a roll of jumper up there. There you can see it basically, or you don't. I can tell you they are in the. Can I tell you that? Yeah, they are in the left position. They're in the left position. Oh, that's a very beautiful view you have there. Let's quick check what the left position is. So I'm looking at these. They are in the left position, so they are on the 48 volt jumper position here. So I was like, my thinking was maybe we have them on these two. Then they would still run on 24 volts, but we definitely have them on the left position. Let me quickly remove the camera, then I can. Yeah, there's one pin free. It's a bit difficult to see. But yeah, it's all three have one pin three on the right, so they are on the right power supply. And the fan is also running, by the way. So the steppers get really good cooling. Okay, so we have 1.5A. Let's follow T's lead and play the amperage game a bit. See what happens when we now do 25. We do need to check the specs for the steppers in the front. The back one can take many amps. Front ones might get, I mean, now they get a bit warmer, not hot. I don't want to be responsible. Yeah, it's okay. It's calculated risk. If the drivers get too hot, they will shut off. Motor is very easy to feel. Yeah, now it skips again. I don't want to push the amps a lot higher, to be honest. I mean, now the motors also get still like not hot, they're like warm. So not a big deal. But I don't want to push it over 1.5, to be honest. Like 1.2 should be plenty. I'm just very confused because we get barely more out of the machine as on 24 volts. So T, your assessment is like really pointless. So far is very true. Not getting like a lot of it. I mean, the steppers are much nicer. That's benefit, I guess. Do you need to input shaping now that you have new drivers? Yeah, definitely. Definitely you should do that. But that would only be quality related, and I cannot do this on a table. The table is not good enough. I always have to put it down, and yeah, not going to do that in stream now. Um, Yeah, so it's a bit weird because I would have expected like a lot more oomph. I also like this guy like who put like 48-volt power supply in his ender and he got like incredibly high accelerations, like way more than 20k. 20k, like, don't get me wrong, like this is like more than I ever need. It's just like for the fun of it. I see 20k 600 millimeters here. I mean, we got that, right? Like we have 22 at 1,000. I'm pretty sure somebody has a config for me. I'm also not quite sure if my expectations are just, you know, out there. I mean, what we can do is like if we, I'm pretty sure if we reduce the speed to 500, most likely we can push a lot more acceleration. Yeah, we're also back to 1.2a, right? So it's a bit less current now. That looks pretty unimpressive. I think it skipped some steps because it hits the end stop here. That was 25 with 500. So I think like with the lower speed, like we got better, but still like it's not really impressive. Yeah. How about that? Let's do like speed benchy. Just like with what we have, because like the hot end will be like the limiting factor anyways. And it's not like a speedboat race compliant benchy. Because it's 0.6 millimeter. So it doesn't quite count, but let's still see how quickly we can like whip out a benchy. Shall we do input shaper? Let's quickly do an input shaper run. I just have to put the printer on the floor for that. Luckily, the cable is really long. Let's quickly home. I mean, looking at the printer while doing input shape calibration is not very interesting anyway, so it's not like we are missing a lot. It's calibrating. Here, you can see the full glory of the progress. Just need to be careful to not bump it with my chair. Maybe while we wait for that, we can also prepare our speedboat. So we go to the Enderwire handy models 3D benchy. That's the right material. I think the max volumetric speed here is relatively high. It's like 30 millimeters per second. But the problem is that it's 0.6 millimeter nozzle, so like it needs more flow basically for like the same speed. You should 3D print a handle for top. Yeah, the thing is like where the printer sits. Like, yeah. You see the white thing there? That's where the printer is under, and it has like 2 millimeters of space basically to the top. So there's no handle possible at the moment. Yeah, so this should be fine. I think like there was a bit of headroom left. We could put it to 32 or something, but I think that's not really worth it. Let's go to the speed preset and make a speedboat preset. Let's see. So speed. The accelerations. We've seen it working with like 22 for the most part. So let's just go with like 18,000. We do that for everything because it. I hate that. There's a bug in Orca. It duplicates, like you can't copy paste. It duplicates the model. And for the first layer, let's just go with like 2000. And this is 180,000. That would be optimistic. Then speeds. Technically, we can go up to 500. We've seen that working, right? At 18,000, it should not be a problem. Let's just go to 400 for everything. Not really like fine-tune profile. It will not hit 400. It will not hit 400. It will, if we slice it now, the volumetric flow basically just limits the speed. Yeah, you see here like it goes up to 352 in some spots, but mostly it stays like in the 200 range. How many? So this is at the moment it's 2 walls, which is like 1.2 millimeters. But yeah, that's the thing. Like with a 0.4 millimeter nozzle, right? You would need like half the flow. So instead of like hitting like 300, you could go up to 600 technically without being capped by the flow. But with the 0.6 millimeter hot end, like we're just capped by the flow here. Nevertheless, this is like technically 17-minute benchy, so it's not bad. And it's not like a special optimized thing, right? Like if you do like a speedboat, like they're like optimizing like crazy. It's just like a normal profile with like high speeds. Let's see. I think it's almost done. 132. Yeah, it's done. Let's see what it recommends. I mean, it doesn't really matter what it recommends because we're not going for quality here. Yeah, so for X it's EI again, as before. And so it recommends 6,500, but yeah. And Y is MZV. It was also the same as before, and MZV was 4,000 for Y. So it didn't really like change the recommendations of the input shaper. Okay, let's print the speedboat in air quotes. Ah, I hate this. I don't know why this sometimes happens. Maybe we can also like increase the overhang speed a bit. Yeah, that's shaved off like half a minute. Here we go. Takes quite a while to upload for some reason. Can you go to your filament cooling settings? I want to see. Yeah, I can. So it's basically fan speed 100%. By the way, we can maybe, oh, sorry. If you still want to see the settings, take another look. I was thinking at the moment we are printing at 225 degrees with PLA. Could push it a bit higher to get a bit more flow. The AZ Cowboy one. Choose speed and momentum. Is there a preset for ludicrous speed? I don't think so. I mean, there might be, but I know, for example, Prusa makes very specific profiles for speedboats. Or like, it's not even a profile, right? They have a pre-sliced file where they optimize everything. I forgot what mine is set to, but I adjusted the fan speed threshold. Yeah, so for me, it's always on, basically. Let's see what temperatures are doing. Heating to 60 degrees here. PLA, 150% fan minimum. Yeah. The fan is really good, actually. Like, not sure who watched it or remembers, but we swapped in the. I had like a super shitty fan in the beginning. And it was like not really cooling well, and we swapped in the Honey Badger super high performance whatever fan, which is like 9,000 RPM, and it's really good. Like, it really cools impressively well for a single fan. Okay. So I will keep a hand on emergency stop button. It's gonna be like a bit lower view. Here we go. I still didn't fully tune the Z offset, by the way. With fully tune it, I mean like it's looking. Oh god. Okay, we need to quickly restart that. That's not gonna fly. I don't think this is a success. Yeah, it needs to be a lot lower. I mean, just set it half a layer lower. Heating the hot end and should start any second now. Here we go. That looks better. Yeah, should be kind of okay. Yeah, the bridging speed is very low. So that's the bridging speed we are having at the moment. It's funny that the external parameters are still very slow. Yeah, that's 0.6 millimeter nozzle. That caps the speed quite a bit because just the flow rate is limiting. You see on the side, the flow is like actually not hitting 30. It's not hitting 30 on the flow. Hit the slider. Let's do that. 125. Let's try 150. Yeah, now we're hitting 30 on the flow. Yeah, and the bridging speed we need to increase. Bridging speed does not work well. I'm not sure why the other walls are so slow. I think another thing that kind of keeps it down at the moment is square corner velocity, which is 12. Ah, there he goes. I mean, the first layer looks kind of okay. It's a bit high on one side, but it doesn't look too horrible. Okay, let's see if we can fix the bridging speed a bit. I will it's paused, so the temperature it will keep. So let's just turn off slow down for overhangs. And then the bridging speed. Bridging speed. Oh. Travel needs to be faster. Let's keep the first layer acceleration at 500. Can you speed view in slicer? I want to see after slice. Yeah, I will do. I'm looking for the bridge here. So the internal bridge can be a lot faster. I think we can just go to 300 here. Yeah, so it's the yellow part. I wonder why the infill is so slow. Like all the infill here is blue. So it's like somewhere in the lower section. Oh, so sorry, you don't see the legend. So the yellow one is 200. The blue here is 50. Maybe it's the small parameters here. Helped a bit. Yeah, we're not sure what makes this section here so slow. The blue section. Cooling threshold. That could be it. Yep, that was it. Yep, makes sense. That makes sense. So if we now get the first layer correctly done, I'll move it down another notch. And let's also quickly clean the build plate. Let me quickly grab a paper towel. 1 second. Okay, let's see if that helps. I also moved it down a little bit. So let's cancel the print here and upload a new print. Ah, this is so annoying. I don't know what this is caused by. Transfer. And the models, 3D benchy, slice. By the way, what's the time now? 12 minutes. What happened? Yeah, there's a bug in Orca. I don't know what it caused it, but like sometimes it just says unable to write G code or something, and then you have to create a new project. It's super annoying. And then you have to create a new project, and in the new project, it just can write the G code. Then I don't know. It's a bit weird. What version? I most likely I'm still on beta, which you know I'm asking for trouble. I'm asking for trouble. About this is 2.2 beta 2. So yeah, most likely it's on me. Speaking of beta, Orca, GitHub. Yeah, I'm on 2.2. Orca slicer, GitHub. Oh, there's 2.2 official, so maybe you know, I could drop the beta. Yeah, they updated a lot. Yeah, 2.2 beta 2 was the last beta on that. Okay, let's hope that we don't get like another failure. I think it's good that like the first layer is like, you know, slow. The bridging is still slow. Yeah, bridging is slow. I don't know why. Like, it's most like some cooling setting or something. I don't know. Yeah, but now it caps out at the flow. So now the flow rate is the limit. It's 30. Cooling will be horrible now. The infill is also not the fastest infill. There's also a setting to combine infill combination, which is on. So with infill combination, it only does infill every second layer. Yeah, speed-wise, we hit like 250 on speed. The Y stepper is incredibly quiet. The steppers are quite toasty though. Oh, I think we are losing it. Ah. Maybe we are lucky. Like I hear a bit of like crunchy noise from the nozzle hitting like curling. The Y stepper is super cool. It's only I think these steppers are a bit too small for the amperage. They are quite on limit. Take the bed up to 65 for the first layer. Can do. At the moment it's 60. But so far it's doing okay. Yeah. I also don't hear any collision noise anymore. I mean, the bow looks horrible. It's not well cooled. I think most people do the bolts at 45 angle on the bed. Yeah, I think that makes sense. I don't think Y is the limiting factor here, though. Oh, you mean like at 45° to have better adhesion? Yeah, the steppers for X and X and Z getting quite hot, so that's not like a long term. I do have like cooling blocks. I could attach them. But... So at the moment we are at what are we running them at? We are running them at 1.2 amperes. So this seems to be a bit too much for those steppers. I don't know best thing at all, so I'm not sure why to do it. I could imagine for adhesion. Maybe? I don't know. You know, like when it hits it at a 45° angle, maybe it's a bit more stable. Yeah, so I think generally very underwhelmed, to be honest. I mean, I was aware that like it wouldn't be like a monster printer because of just the limitation from the hot end, but I expected a lot more in terms of like movement performance. Maybe it's the wrong motors for that. Could be. I mean, it's not slow, right? Don't get me wrong. Right now, like the main limitation is the cooling. So if I would want to print at these speeds in like production, basically, I would need more cooling. That's at the moment like the limiting factor. So it's not a motion system per se. It's not the hot end. It's just cooling. So it says 3 minutes left. Let's see. What layer height am I using? Oh, it's actually 0.28 layer height. So I'm cheating. But actually not sure if like if we would slice it with 0.2 layer height, I don't think like it would take like a lot longer. Because we're kind of capped from the flow. If I reslice it with 0.2, yeah, now it has the same same error again. Yeah, if I slice it with 0.2 instead of 0.28, it's like 30 seconds slower. It's really like the flow rate that mostly limits there. Almost there. The bridging actually... No! Go on! Come on! It's so close. I mean, besides cooling being really crappy, man, it's also like it's really like I need to get like a different filament for testing. Like this shows up really badly on camera. But yeah, like cooling is less so optimal. But besides that, kind of looks okay. Like if you check here, like this really looks horrible on camera. I don't know why. Like the layer stacking per se looks quite okay. So that's it's not bad besides the cooling. I mean, that's all cooling, but like yeah, where cooling doesn't matter so much, like here on the beams, it kind of looks stacking wise, like also here from the back, it looks really, really okay actually. Okay. I would basically take this as a cutoff point for today. I didn't want to stream super long today because tomorrow I have to get up very early. So I need some sleep. Yeah, kind of mixed feelings about the entire thing, to be honest. So it works. I would say the printer is quieter than it was before with the old steppers. Speaking of quiet, let's turn off the fan. But it's like I would have expected like a big bump in the motion ability, and I think we went up quite a bit. Don't get me wrong. We went from 16K acceleration to, let me just before I forget it, like let me reduce the run current to 1 again. From 16K to 22K. So it's like quite a bit more, but it's not like incredibly insane more. I would have expected like at least 30, to be honest. I'm pretty sure T, you're right, and there's like more settings. There's most likely just some magic setting. And there are incredibly many settings basically that are quite difficult with the steppers. Like it's really like mystery. So most likely, yeah, it's just some setting or something. And yeah, so to update my plans, next week we're gonna stream. I'm not sure yet what. I might just do like kind of like print and chill maintenance stream for the V0, just like like tensioning belts, doing some prints, checking some stuff. Quite low key and chill. The week after is most likely, let me check. So on the 20th of November, I got shitload. Yeah, exactly. So next week, Friday, I definitely stream. And then the week after, I get like a lot of furniture. So I most likely will just be staying at my new place building furniture. Because I'm a bit in a pinch there time-wise. The same on the 29th. So potentially I might not stream for 2 weeks then. And then hopefully on the 6th of December, I'm back. Need to see. It really depends a bit on where my stuff is and how it works. I try to keep everything printer related here. So maybe we can do like a stream next week or the week after. Yeah, maybe we can do like a every 2 week schedule for like mid-December or until like mid-December. Something like that. Did it run spread south chop or spread cycle? I think it ran spread cycle. It should have at least. But I'm not quite 100% sure on that one actually. I was also wondering, but if you check the so basically how it was configured right now for the run, I disabled this auto tune section, and the stealth chop threshold was not set. So I'm not quite sure what the default of stealth chop is, but I would assume it's 0 to be honest. We can quickly check the. Yeah, it defaults to 0, so stealth chop was off. Yeah, below. So it definitely wasn't spread cycle. So that shouldn't be the issue. Might also be an issue with micro stepping or stuff like that. Yeah, there are lots of options. But generally, I have this TMC Auto Tune plugin here, which should set all these values for you. So you just give it like a tuning goal, which in this case is performance, and then it should like configure everything for performance for you, like all these like driver underscore something values. I had to run mine spread cycle at all times or it will skip steps. It's actually interesting, like on this machine, what I noticed with the old steppers, step drivers, is that they performed equally good in spread cycle for whatever reason. Like spread cycle was on Y, spread cycle was even a bit better. Don't ask me why. Well, a bit weird, but yeah. Cool. Okay, then let's wrap it up. Thank you everyone for tuning in and for chatting and supporting me. And I'll do some research. Maybe there's something we can do. And then see you next week for sure. And then the week after we see. I'll tell you next week. Cool. As always, enjoy your weekend and see you next week. Bye.